Very good. If you write down nothing but this, here's what you do. I'm going to give you a website. DAACKM.GITHUB.io. DAACKM.GITHUB.io. That's my website. And if you want to go back and see the parts of this clinic again, or see some other things that I teach, that's the one place to go for all the information. And secondly, what's the main takeaway that you're going to get from this clinic? Don't enter 3D printing lightly. It's as complicated as DCC, but it can be really a lot of fun if you really commit to it, but don't think that it's going to be a piece of cake. Jeff, how many people do we have in the room?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Okay, could I have a show of hands of how many of you have already tried 3D printing?
1, 2, 3.
3. Well, this is positioned pretty well for you all. So let's roll tape.
All right. See if I can do this correct.
Oh, it's the wrong clinic.
Oh. Sorry about that, Dave. I know what you're thinking.
Problem.
I know what you're thinking, Dave.
I teach 5 different clinics, guys, and you're going to get 2 of them today.
Where did it go? Where did it go? I had it. Where did it go? Where did it go? I think it downloaded it already. I had it up. It just, sorry, one. You're on such a roll, too, Dave. Here it is.
There we go.
Can't hear the sound.
Secrets for things I created myself.
Hold on, was there somebody online said they couldn't hear the sound?
No, I'm getting this mild static.
It's a bit scratchy. If you go down to the control at the very bottom, where you've got the right arrow, to the right of that, maybe you can write that slider over to the right.
Okay, it may be really loud here, guys.
Before we go too far, here is my 3D printer, an Ender 3O, which I bought from Microcenter in July 2020.
I don't know if it's just me, but all I'm hearing is chit-chit-chit-chit-chit-chit.
Dave, do you hear the sound?
I hear the same thing. I hear a lot of breakup, like the audio is not going over a free conference call.
Well, I have no idea why that is, because you and I can talk.
Yeah.
I mean, it's the same. It's the same thing. It's the sound from the computer going into the microphone, just like.
Is there a setting on the audio? Is there a setting that you can say to use computer audio? Because I think the audio is not going through the...
Yeah, I completely agree. You want to do the audio through the computer rather than through the microphone and being picked up by the speaker.
Right.
You guys can see what I'm seeing, right?
Yeah.
Yeah, I don't.
Yeah, and you're perfectly clear.
No, but you can see my screen. I don't see an option here. This is.
There's something under advanced. No.
Try same as system, where you select a microphone. Over to the left of that panel, select a microphone. That would work, yeah.
Can you hear me now?
Yeah.
I can't.
Well, you could hear me before anyway, right?
You're right, yeah.
You could also try unchecking the use ambient noise reduction.
All right. It would automatically adjust level. You want to try that?
Yeah. There we go.
All right. Let's see if this works. Sorry, guys.
Not any better.
Did you say better?
No, it's not.
Oh.
It's the same.
I got no idea. Anybody got any ideas?
Where's the microphone? You have to change the microphone is.
Yeah, if you put your microphone right by the speaker, that might help a little bit.
I think David's onto it. We got to figure out if there's a way to make it use the computer audio directly instead of going out and back in.
Yeah, that would be better, but...
Does this show up in the mixer somewhere?
I got no idea.
On the speaker thing?
Video?
No, the presentation.
Down on the bottom right.
This? This?
Yeah.
Yeah, sorry. What's that?
You got a mixer. No, all the way down to the bottom lower right of your screen.
Yeah?
Okay. If there's anything there you can adjust. Yeah, the speaker thing. To the right. To the right. That one, yeah. To the mixer.
Can you pause it and call the cell phone? Computer on your phone.
Slider.
I can't. Whoever's talking, I can't hear you very well either.
See what the mixer screen? There's a slider, so there's more things to the right. Yeah. Oh well.
Click on the upper left corner of the presentation button on the right.
This one?
Four dots.
4 dots. Yeah.
Yeah, character place and start system.
Back in black? Okay.
Jeff, could we go over to the panel all the way on the left where it says select a microphone?
On which panel? This?
Further to the left. Where it says select a microphone?
Select a microphone.
Or is that my panel?
It's on my panel. I don't see a select a microphone anywhere.
Okay. On your lower right where you have your mute button and the up arrow right next to it, click on the up arrow just to the right of the mute button.
He's on his presentation. He's talking about his image. Sorry about this. Right.
Let's try audio.
Lower left.
Okay. See that a little bit more to the left. Now that up arrow. Okay, let's go to same as system for a selector microphone. That was select a speaker. So let's try select a microphone.
So I have a suggestion. I'm looking on the web. It says if you stop sharing and then you go back to sharing, one of the things you can choose before you share your screen is to use PC audio. So try turning off sharing and then reshare. You're still sharing. No, you're not sharing. Okay, so reshare. If there's a button on the share before you actually say go to use PC audio.
Okay.
Google says share PC audio box.
Okay. Where's my,
Still sharing, right? So did you see it before you started sharing?
hold on.
Welcome to this clinic on what you can do with the 3D printer.
How was that?
Much better.
This is really scary that we figured that out, but we figured that out. Oops, sorry for the delay.
In model railroading. So, what are we going to cover today? How about things like how I came to decide that I would invest in my own 3D printer, what it is going to cost, the most important factor in buying a 3D printer, where to go for designs you can print, things I learned about how to keep my printer and myself happy, and some design secrets for things I created myself. Before we go too far, here is my 3D printer, an Ender 3 Pro, which I bought from Micro Center in July 2020. And here are some of the objects I have printed successfully. Some I obtained from libraries, and some I designed myself. And here are some of the objects that were not so successful. 3D printing can be frustrating. You can take as many notes as you like, but be advised there is a handout with what I consider to be the main points at my website at http://daacam.github.io. Information on other clinics I have taught can be found there as well. But today, I would like to share my observation that using a 3D printer is kind of like stages of love. There are several stages: curiosity, commitment, learning to love, raising a family, sharing secrets, and mastery of relationships. Like love, it will be expensive, complex, but can be highly rewarding if you are willing to invest and learn. I know you are already curious about 3D printing and model railroading because here you are, watching a webinar on the topic. You've probably watched several other YouTube videos as well, maybe browsed Amazon for printers, or have some magazine articles hidden away. It's time you have a conversation with Uncle Dave about the facts of life of 3D printing and model railroading. So sit down and listen. If you think that 3D printing is as simple as it appears in videos and magazines, you are mistaken and will be frustrated. If you think 3D printing is quick, you are as mistaken as trying to time paint drying with a stopwatch. If you think that 3D printing will save you money, you are mistaken and will waste money. But if you think 3D printing will make your railroad more fascinating and unique, and are willing to invest and grow with it, maybe you and 3D printing might have a future together. Like DCC, 3D printing is a sub-hobby all by itself. So, how does 3D printing work? To make something with a 3D printer, you need to have a model and either use a service bureau or have slicer software and access to a 3D printer. A model is a collection of three-dimensional objects, such as cubes and cylinders, which together represent a shape you wish to create. Models can be created in computer-aided design software, and entry-level CAD software is often free. Or models can be downloaded from massive online libraries of models. Models often exist in the STL file format for stereolithography. Service bureaus are companies who have internet sites where you upload your STL models and they will print them for you for a somewhat reasonable fee and a large elapsed time. Otherwise, if you have access to a 3D printer, you can feed your models into a slicer, which will convert your model into a multitude of instructions for where to deposit a series of layers of filament with your printer. These instructions are called G-code. If all goes well, after 10 minutes to 24 hours, you may have created a trash can or the parts to construct an HO building. For my first project, I decided I wanted to create walls and floors for a 3-story building, into which I would add LEDs for random lighting. I downloaded Tinkercad design software, measured the internal dimensions of my Woodland Scenics building, and in about 5 hours, I had learned enough to have a model I liked. I also learned that building size models can take between 6 to 24 hours to print. So staying in a library waiting for something to print was not going to happen, even if I could find a library which had a 3D printer, a rare beast in the St. Louis metro area. So I uploaded my model to the MakeXYZ.com website, and after several iterations, it worked. But the model was big and expensive to print. Each iteration cost about $40 and 2 weeks of elapsed time from submission to delivery. Should I really consider buying my own printer? What is it going to cost? You can spend anywhere from $140 to several thousands of dollars on the printer itself. I was willing to spend $300 for my first printer, and for that I bought a machine that could print objects 220 millimeters by 220 millimeters in the X and Y dimension and 250 millimeters in height. It has a heated bed, aka a build platform, which makes it easier to separate the printed object from the platform. It has one extrusion system, which means it can print in only one color at a time. It can print using PLA, polylactic acid filament, a plant-based and environmentally friendly product which is readily available in about 3 dozen colors. PLA is generally available for about $25 per kilogram roll, and a truck or other HO feature might weigh 25 grams, making the object cost less than $1 in filament. Rolls smaller than a kilogram are also available. But if you want to print in colors other than white, and you don't like to paint them, you will be buying multiple rolls of filament. Yes, you can sometimes buy filament in multi-packs with multiple colors, but sometimes the quality is not as good, with the loops of filament on the rolls sticking to each other and not feeding properly into the extruder. So do the math. Good filament in multiple colors can run several hundreds of dollars. Designing your own models is not for sissies, but you don't necessarily have to design them yourself. You can visit a library, search for an object of interest, and download as many as you like for printing anywhere you like. Library objects are like the women I dated in high school and college. There are millions of them. And instead of checking them out, you can download them and they are yours forever, with many of them being free. I visited Thingiverse.com and did a search using the keyword dumpster, and dozens of images popped to my screen, most of them free. When I clicked on one, a download button appeared, and when I clicked on the button, Thingiverse would send them to the download folder of my PC in the form of a zip folder. Inside the zip folder was a files folder containing one or more STL files I could scale or print. Sometimes there is only a single file in the files folder, which I would copy and paste into a folder on my hard drive. But other times, the zip file contains multiple files with separate parts in separate files, in which case I would create a subfolder to store all of these related files. But like potato chips, it's hard to stop at one, so I often ended up downloading several different models, deciding later which one I wanted to actually print. Thingiverse is by no means the only 3D library. There is also 3dwarehouse.sketchup.com, which has millions of objects of its own, some of them free. Like Tinkercad, SketchUp is another piece of design software, and the 2017 version is free. 3D Warehouse images are often stored in SketchUp's proprietary file format, which means they can be modified and eventually can be exported into STL files for printing. But I have been less than totally successful with printing objects from the 3D Warehouse library for reasons I have yet to understand. Tinkercad has its own library of designs. The Gallery tab on the Tinkercad dashboard allows you to enter keywords and retrieve objects from its library. The libraries keep on a-coming. TurboSquid is another one I like, although many of their objects come with a fee. Libraries and service bureaus sound like a fantastic idea, but appearances can be deceiving. When downsized to HO scale, many of the objects can lose integrity. When I tried to print some dumpsters, the walls became too thin to use. When I tried to print motorcycles, the wheel spokes and handlebars melted into mush, and the turnaround time it took for a model to be fabricated and delivered to my door was more than I could tolerate. So, just like some of the girls that I dated, the overall experience turned out to be something other than I thought it might be. But the experience was pleasant enough that I decided to buy a 3D printer. I was ready for commitment. Commitment. But where to begin? Amazon, of course. A search for 3D printers uncovered 209 of them, from $139.99 to over $15,000. I had already decided I was willing to spend up to $300, but I wanted a rating of at least 4 stars. I saw that there were close to 70 options available under $300. I had a starting point. I fell in love with the unit from Monoprice, their Cadet model. Its videos on YouTube suggested that it was simple enough for children, and their reviewers seemed to like it well enough. It advertised a self-leveling bed, which seemed attractive for a newbie like me. Its build plate was limited to 100 millimeters on a side, kind of small, but as a first-timer, I was willing to overlook that limitation. I ordered one, and it arrived in 2 days, dead on arrival. Several hours in chat with their technical support, and the determination was that I should send it back to Amazon for replacement. The replacement arrived in 2 days, and it worked for a week, then again failed. No amount of thoughts, prayers, or online chats could bring it back to life. So it was again returned, this time for a refund. That leads us to the most important factor in buying a 3D printer. Make sure you have 30 days to return it for a full refund. I was sure glad Amazon had a 30-day satisfaction guarantee, because I learned not all commitments are going to last. It was probably a blessing in disguise. That Monoprice printer was probably too small for an HO modeler. When you buy a 3D printer, make sure it is large enough to create a 3-story building in your scale, or whatever you think you might ever want to print. 200 millimeters cubic has worked well for my HO models. Sadder but wiser, I returned to Amazon, and this time noticed that many of the printers in my price range looked similar, but were just offered from different resellers. I learned that the underlying model was an Ender 3 from Creality. It was offered as a base Ender 3 model and also an upgraded Ender 3 Pro. The YouTube videos seemed supportive, so I ordered and received an Ender 3 Pro for $250. But before unpacking, I received an email from Micro Center offering the same model for $200. So back my unit went to Amazon, and off I went to Micro Center and bought the unit I am using now. Turns out that Creality was about to release version 2 of the Ender 3 with even more features than my Pro version, but for about $60 more. Most of the V2 features can be purchased for the Pro as aftermarket items, and I was unwilling to wait. I bought an Ender 3 Pro. If I had to do it over again, I would buy the V2, again from Micro Center. But the time between when I purchased the unit and the V2 was available on the street, I got about 4 weeks of good experience and am satisfied with my purchase. Now it's time for learning to love. Now that you have decided which printer you think you want, but before you shell out your hard-earned cash, spend a couple of hours on YouTube and view some videos on how to unbox and set it up. You will save time and maybe some frustration. Just enter the name of the model you are considering and words like unbox or set up. Other words like problems and troubleshooting can be illuminating as well. No one is perfect, and neither are any 3D printers. It takes time to learn the little things that make a relationship successful and happy, and I call this phase learning to love. For starters, my 3D printer came with some assembly required. The instructions were a series of illustrated steps without any narrative. Think IKEA. But the requisite tools were included, and assembly took less than an hour. In retrospect, I was glad it was not plug and play, because I learned a bit about the internals. The unit could be connected directly to a PC as a USB printer, but I chose the option to drive the printer from the SD card that came with the printer. The SD card even came with some demonstration files on it. I leveled the print bed and inserted the SD card. I loaded some PLA filament into the extruder and turned the machine on. The display sprang to life. The actions are controlled by turning a knob and pushing the knob when the desired action is highlighted. I selected a model to print, and things started happening. I was printing an object. Success! I admit it. I had grandchildren with me that weekend, and I spent the next 2 days downloading and printing Pokemon characters and bathtub boats for their amusement. But it got me going, and I suggest you start by doing the same thing. A word to the wise. You will go through more than one extruder nozzle, so buy some spares. I bought a box of 24 from Amazon for my Ender 3 Pro, and I'm glad I did. I also bought extra brass extruder wheels. These parts are considered expendables. While you are at it, buy a kilogram roll of white 1.75 millimeter PLA filament. Not much of this comes with the printer. I like filament from Everyone from Amazon. Tool-wise, if you need to change a nozzle, a 1/4 inch ratchet wrench with a 6 millimeter socket will come in handy. If you are using your own printer, you will need to learn about a step called slicing. Slicing is a software step which takes the STL file created by a CAD program and transforms its contents into a G-code file containing instructions to tell the printer where to move the axes and how much filament to extrude. A version of the Cura slicing program came with my printer, but it was at least 3 major releases behind the version that was available for free on the web. So I quickly downloaded the current release and set aside the one from the printer vendor. Slicer software can work with many different printers, and after installation, it does require you to tell it what printer you are using. Now, I just import a model into the slicer, but I may want to alter its size. To do so in Cura, I click on the object and then on the button on the left that looks like 2 hourglasses in different sizes. When I do so, the slicer displays the width, depth, and height of the object, and I can enter new values in millimeters or percentage. If the uniform scaling box is checked, a change of size in one dimension will also alter the others proportionally, or if unchecked, the size will be altered in only one dimension. After that, it is little more than clicking on the Slice button and saving the G-code file to your SD card or hard disk for eventual printing. There are options, the most common being selection of the quality you want, setting the temperature specifications of your filament, and what type of build plate adhesion you want. If the object has legs, such as found on a dumpster or table, you may want a raft to make sure the object does not separate from the bed. But if the surface of the object is flat, like the back of a wall, then no special adhesion may be required. There are about 6 other settings in the slicer that might be useful to me once I learn how to use them. Leveling the bed must be done during the assembly process and regularly thereafter. The replacement springs helped hold the bed in place, but I still level the bed after about every 10 hours or so of printing. It takes less than 2 minutes to do so, and is well worth the effort. If prints don't want to adhere to the bed, leveling is one of the several things I check. Another is scrubbing down the bed with isopropyl alcohol, 91%, after each large print. And I do mean scrub, not wipe down. Oils on the magnetic cover will get you every time, and the result will be a spaghetti monster. I generally watch the extruder deposit the first layer before walking away. If the first layer is solid, you have about a 90% chance that everything above it will be stable. Inserting filament into the extruder motor mechanism is easier once you learn to cut the end square and straighten about 2 inches of filament before trying to load it. Since the filament comes on a roll, it has a certain curve to it, and if not straightened, makes it almost impossible to get it into the Bowden tube. Sometimes it helps to rotate the filament a bit. If it takes me more than 3 tries to get it threaded into the Bowden tube, either I didn't straighten the filament enough, or I am pressing too hard on the mechanism lever. You will learn with experience. And not all filaments are created equal. In the beginning, I wanted as many colors as I could afford, so I bought a multi-pack from Gizmo Dorks, and was not as pleased as I had hoped, mainly because the filament tend to get stuck on the spool and break, which of course ruined the print. I have been happy with the smooth running filament from everyone, and it tends to be my filament of choice. I bought a 3-pack of metallic filaments, gold, silver, and copper, sold by a company with the strange name of HZST3D, and was pleased with the result. Mica 3D makes some good filament, but it is just a little bit sticky, so I have taken to unrolling several meters of filament from the roll at the beginning of the job, re-rolling it back before printing actually starts, and then repeating this exercise several times during the job, especially if it is a large job. All of the above are sold through Amazon. Finally, I like the deep colors from Coax, made in the USA, but you will have to search for them on the web, as Amazon does not carry their brand. I have been successful spray painting my 3D prints and painting with brush-on acrylics. I have had no trouble with gluing 3D parts to each other or to styrene with either CA or bonding. I learned the hard way that PLA filament rolls should be stored in airtight containers, along with desiccant packets. Otherwise, they will absorb water and require drying before they can be used. Before long, it was time to start raising a family of HO parts for my railroad. Again, I went to the libraries and downloaded and printed some detail parts, including cats and dogs, awnings, trash cans, tires, dumpsters, cars, trucks, motorcycles, boats, and small buildings, with varying success. Success seems to be related to how much I needed to alter the scale. If an object needs to be reduced by more than 50%, I am asking for trouble. The components that are small to begin with, like cable wires, wheel spokes, and window frames, are often too fragile to survive. My best luck seemed to be from Thingiverse, when I included HO scale in the search criteria. Things like dumpsters, which I expected would scale well down to even 10%, often look fragile when printed. But there are so many good models out there that you will probably want to push the envelope anyway. Just be advised. I did want to share a few models I downloaded and printed from Thingiverse, which turned out well. Among the first I printed were houses, the Ionia, the Dayton, and the HO scale tenant's house, and I liked the results. I also liked the miner's cottage from Badger Breath. For accessories, I liked HO scale travel trailers, HO scale office trailer, HO scale picnic table, gazebo, and containers, HO stackable version 4, and many more. There are some nice standalone structures, such as gas stations, diners, a theater, and brick commercial buildings. Just open Thingiverse and search for HO scale. I was disappointed that I found so few HO vehicles that would print without supports. Designers should create vehicles with separate tires and wheels to allow the body to print without supports. I print most of these in white to minimize filament changes, and gluing pieces painted with spray paint has not been a problem. It's no secret that I was successful in 3D printing some of my own designs, so may I share a few? My first original creation was a building interior I used in my amazing Arduino animations clinic. This interior is designed to separate rooms and floors, allowing each room to be lit independently. The trickiest part of any printing is to make sure the object sticks to the build plate, and for best results, I designed the object such that the largest flat surface lays directly on the build plate. In this case, the back wall of the interior is on the plate, with the walls, floors, and ceiling growing up from it. I learned that, at least in Tinkercad, it is not enough for walls and floors to meet. They must actually intersect. Consider a building where there is 35 millimeters between the top of one floor and the bottom of the next floor. For our purposes, assume that the floors are 2 millimeters thick. How tall should the walls be? 35 millimeters? Such touching joints did not work for me, but 39 millimeter walls, walls that actually penetrated the floors above and below, did. This is actually easier to do than it sounds, because Tinkercad has an align function that makes it easy. Once in place, I group all the walls and floors to make a single unit, then print. I use 5-volt LEDs on a roll to light my rooms, and control them with an Arduino microprocessor. I decorated the walls with images I downloaded from the internet and attached with rubber cement. Hot tubs were not really a thing back in my transition era layout, but I always wanted one in real life, so I decided to design one. It's really nothing more than a bunch of cylindrical solids and holes. My wife insisted, for safety's sake, the tub should have steps and a handrail. Brown paint decorated the outside of the tub, white the inside, add unpainted seated figures covered with swimsuits and COVID-19 masks, and voila! We had a socially distanced soaking experience. I used clear silicone caulk and a drop of clear blue paint for the water, swirling a toothpick to simulate waves and bubbles. Next, I decided my layout room needed a herald of my layout, the Baden, Vogt, and De Smet, the 3 elementary schools I attended as a child. But what was I going to use for typography? My official logo uses Windows Algerian typeface, and Tinkercad is limited to 3 pretty nondescript fonts. Time for trick number 1, a little complicated but very effective. I used PowerPoint's text box tool and entered the name of my railroad, Baden, Vogt, and De Smet, on 3 lines and indented. I changed the font to Algerian and increased the font size to 100 points, about enough to occupy the entire page. I clicked on File, then Save As, and down at the bottom, where it says Save As Type, I selected a PDF file type and clicked the Save button. Since that was the only thing in this particular presentation, the name of the railroad was all that was saved. But if you desire, you could use the Options button to save just the current selection or a specific page. But so what? Tinkercad and Cura don't know how to import a PDF file. True, but the anyconv.com website does know how to convert PDF files into STL files, which both Tinkercad and Cura can import. So I opened anyconv.com, navigated to the PDF file which contained my Algerian text, told anyconv that I wanted it converted to STL format, and hit the Convert button. Once converted, I hit the Download button, and immediately my PDF file was converted into an STL object and placed in my Downloads folder, which can then be imported into Tinkercad. In Tinkercad, I imported the new STL incarnation of my railroad name. The text is tiny, so I upped the scale factor from 100 to 10,000 and started the import. Once the import was completed, I reduced the height of my text to 2 millimeters and lifted the text to 2 millimeters off the build plate. I rotated the text 45 degrees and moved it into my desired position. My extruder can extrude only one color filament at a time, but I can't export just certain parts into printable objects for the slicer. So I first exported the purple field into one file, and next the gold rim and text into another. My plan was to print the purple file, and when it completes, I'll change the filament to gold and print the second one on top. But things are about to get tricky. It is a fact that if an object is suspended in air, like my gold rim and lettering, by default, the Cura slicer will automatically drop it back down to the build plate, ignoring the fact that we wanted to suspend it above the first layer. This means that the second layer will not float on top of the first, unless you know a trick. There is a special G-code command, M206, which we can insert into the beginning of any print job, which will offset the height of all subsequent extrusion commands. How do we make this happen? We do so by opening Cura's Preferences tab, then on Configure Cura, then on Printers and Machine Settings. In the lower left is a box labeled Start G-Code. I scrolled down to the very bottom and added a new line, M206 space Z-1.98, to add an offset of 1.98 millimeters to all subsequent extruder movements in the Z-axis, thus raising them above the back of the logo. Why 1.98? Well, the background is 2.00 millimeters tall, and I wanted the gold to be ever so slightly attached to the background, so I made the offset just a bit shorter than the underlying field, and it worked. If I had made the background 1.50 millimeters thick, I would have made the offset 1.48, and so forth. I also added a line, M206 Z-0.00, at the end of the end G-code block to reset the Z-axis offset at the end of each print job. After slicing the gold rim and letters, go back into the Start G-code box and place a semicolon in front of the M206 line, which will turn it into a comment, and then all subsequent slices will drop back to the build plate. I like to keep the line there in case I again want to raise a layer, but if I don't turn it off, all subsequent designs will be elevated and turn into spaghetti monsters. With the semicolon placed at the start of the M206 line in the Start G-code section, I printed the first layer in purple. I then removed the semicolon to elevate the gold layer and printed it, and it worked. I then replaced the semicolon to turn off the offset elevation, and I was ready to print another non-elevated object. Once I got the hang of it, I made some additional heralds for friends. Next, I used a similar overlay technique to create a billboard for radio station KDMR, which delivers news, farm reports, and sports to the surrounding area. Yes, I could have printed the call letters in station format separately and then glued them to its backer board, but once I learned the overlay technique, I kind of liked using it. The billboard design and support legs are available on Tinkercad under my name. But don't think that just because I have shown you a few successful 3D prints, that everything about 3D printing is sunshine and roses. Like any relationship, there will be times when you are disappointed and disillusioned. Filament will break, the nozzle will clog, and the Bowden tube will get sticky and need replacement. You will need to learn how to recover. After totally clogging my printer's hot end, I learned how to clean it by visiting YouTube and searching for Bowden Tube Gap by Tom Tullis from the Tomb of 3D Printed Horrors. I ended up removing the extruder fan, scraping solidified filament from the hot end, removing the nozzle, reaming the hot end with the Bowden tube, and putting it all back together. I was sure glad I bought extra 0.4 millimeter nozzles, because the old one was pretty shot. Despite the strange name of his website, Tom Tullis has a lot of useful operational hints, so you might want to browse what he has. So what have I done lately? I have found quite a few more models in libraries that have contributed to my layout. I found this radio antenna and Quonset hut design on Thingiverse and added a blinking LED to the top using an Arduino microprocessor. Here is Green's Cafe, also from Thingiverse. The sign over the door is a custom decal of mine. I modified Green's a bit in Tinkercad to create Bubba's Beer, Brats, Bait, and Bullets, and I designed the fence myself in PowerPoint, a technique I describe in my clinic on 2.5D CAD. I found a designer with whom I collaborated to create the bedroom units and the office of the Coral Court Motel in St. Louis, an infamous no-tell motel on Route 66 back in the day. Other downloads include this service station and bus station. Here we have a bakery. I printed throttle holders and stretched one into a holder for 3x5 carts. On my own, I created windows and a rustic door using the layered trick. As my skills improved, I learned how to design board and batten siding, clapboard siding, and corrugated roofing, which led to the creation of a tractor shed. Highway overpass decorations, pedestrian dividers, picnic tables, and a picnic pavilion as well. I now make baffles for speakers for sound decoders in DCC locomotives. I make supports for signs. I even created a replacement part for an old Atlas locomotive when I dropped a small plastic pin on the floor and could not find it. My mind has evolved to the point that if I get an idea, I now ask myself, how can I create that on my 3D printer? I am getting pretty good at consistent success with my Ender 3 Pro. Keeping my magnetic bed scrubbed down with 91% isopropyl alcohol made a big difference in object adhesion. I still level the bed regularly, but I am down to every other day. I don't crash the nozzle into the underlying object anymore when doing layered prints. I store my filament in plastic bags with desiccant. I am having a lot of fun. If you would like to have a handout containing the major points of this clinic, please visit my website at http://daacm.github.io or email me at acmans@charter.net. I expect that in 7 to 10 years, 3D printers will be as ubiquitous in the home as personal computers are today. Right now, the path is not easy. The road is expensive, but the journey is its own reward. If you like what you have seen and can accept and learn from the bumps along the journey, I hope you enjoy the rewards. Thanks for joining me along the road.
All right, Dave.
All right. Well, thank you all for listening to this. Just a little bit of information about what I am doing right now. My 3D printer is gummed up. I got it all full of filament, and I was printing something that was too small, and it didn't adhere to the build plate, and so now I got to clean it out like I learned how to do from Tom Tullis in his Tomb of 3D Printed Horrors. I'm trying to build some shake shingles for the top of an old shed, a roof-on shed, and I made it too thin to begin with. So you're going to learn, even now with a year and a half of experience, I'm still coming up with things where I got to clean it out and go all over again. I've been working with some PLA, which is wood impregnated, and that is more abrasive, and it tends to wear out my nozzles. So I change nozzles fairly frequently. So don't think that 3D printing is going to be your answer to everything that you do, although it's really pretty good. I know I will probably never buy another Woodland Scenic building because there are so many great models out there, especially on Thingiverse, if you search for HO scale. Now, if you try to downscale something from HO to N, well, it may not survive too well. So those are some of the main takeaways. It's fun. but it's a learning experience, and like working on an old car, sometimes it takes something to keep the thing running. So, Jeff, what do we have there in the way of questions?
I'll start with my own question. I'm not sure if anybody else has a question, but I'll start with my own question. When you print one, is it ready to be painted, or do you have to do some sort of work before you paint it? Do you have to sand it or anything?
Generally not too much. A lot of the buildings that I have downloaded from Thingiverse are brick, so there's a detail in there and nothing really to sand off too much. They're generally pretty clean. You may want to take a knife and scrape the side a little bit because there may be whiskers on it. I have a model right here that you saw in the...
Did I lose him? I'm muted. I muted? Are you muted, Dave?
I was for a little bit when I moved my model in here and I hit the mute button on my keyboard. See, that's what happens when you go off script. But if you look in the tower, you won't be able to see it because we don't have the resolution. But between the individual triangles, there are little whiskers, just little bits of filament that if this was going to be a contest model, I would have gotten in there and cleaned them up a little bit better. Maybe if I altered some of the temperatures, that wouldn't have had quite as many whiskers. So generally, they're pretty clean when they come out of the printer, unless you got a lot of detail parts like these little cross members in the antenna.
Okay.
Yeah, it works pretty well. Depends, again, on your level of what you consider to be good. The top of the Quonset hut has a little bit of striations in it that could have been cleaned up with sanding.
Kaylee has a question.
Hey, Dave, how's it going? Thank you for presenting. But a question for you. In the early part of your presentation, you had an aversion to support. So I'm curious to understand why.
Okay, give me that again, Jeff. It didn't quite come through.
She said you had an aversion to supports early on. Why was that?
Well, that was talking about the vehicles. If you think about a car or a truck, you know, it's suspended on its tires, and the frame underneath has nothing to support it because it's maybe 4 millimeters in the air. I have not gotten good yet at doing supports for things which are suspended in the air. I've got another clinic in my head where I want to show how to build figures, human figures. But often the arms, if they're pointing forward, they would have to be supported because there's only so much you can cantilever out there. So I need to get better at supports, but I have found that the automatic supports that Cura can make for me just haven't done the job. So I have more to learn. Have you had better luck?
I printed resin, so I've had about 50% success rate with that. So yeah, no, I understand where you're coming from. I was just kind of curious because I know some people are just averse to printing support because they just don't want to deal with the cleanup, and I wasn't sure if that was the case for you.
Well, it depends on what the pieces work for you when it's done. I wanted to animate a figure of a grandma carrying a pie. And so her arms are going to be out front holding the pie. And I've got to do supports for that because the cantilever of the arms just doesn't work as far as I've known so far. I have more to learn here. You mentioned that you use a resin printer. I don't discuss that in my clinic. There are two types of printers, one that uses filament, like PLA, and another that uses resin. PLA is a little bit more environmentally friendly, and resin is just not something that I got into.
Okay. Any other questions? Yep.
I got a comment. Can you hear me, sir?
I can hear, but I'm going to have to ask Jeff probably.
Yeah, unfortunately, it's probably the fan of the projector right here.
I'll come up front.
Bob here has a question for you or a comment.
Comment. I went to the NER convention last week, and actually the first clinic I saw was on 3D printing. This fellow is using a LiDAR scanner. Now, a LiDAR scanner is available on the iPhone 12, which means it's coming down to the consumer level. And he walks around, scans it, and imports that, and he's using SketchUp and printing out subway cars. So you can't buy a model of a subway car, Boston or Philadelphia. I handled one of the cars, and it's just a fantastic print. I'm just saying, that technology is coming, and we'll be able to scan something and put it right into your file, and it'll print it.
I've seen some things like that. I would have loved to have been in that clinic. Just remember, it's never as easy as it looks. When the pro does it, there's so much that you're not hearing, but you can learn if you're willing to invest. And that, I think, you probably don't even need an iPhone 12. I have a love-hate relationship with my cell phone, so I haven't gotten into that yet. But I think you're right. I think there's a future there. And we'll be seeing more clinics on that, I'm sure.
All right, thank you, Dan. Dave, I think what we're going to do is go and switch to the other clinic. That's all right?
That'd be fine. Are we going to take a break? I'm fine. But
you may want a 5-minute break for the next one, or 5-minute break, and then Dave's going to spend the 5 minutes listing the millions of girls he went out with in college.
I've been married 49 years next week. I got lucky.
All right, I'm going to pull up your other clinic while we take a 5-minute break. It's back at 11:30.
Very good. Thanks for tuning in to this entry-level
Well, I'll tell you, Dave, while we're waiting, while we're spending 5 minutes, I took a lot away from that clinic. It was very easy for me to understand how it happens, right?
Well, good.
And I'll tell you, I've looked at like Shapeways.
Yeah.
Where you can basically just order someone's work already.
Yes.
They send you the gizmo, whatever it is.
Yep.
It's just a staggering price. It usually makes me not do it when you're like, okay, it's a trash can for $17.
Yeah, and the elapsed time.
Yeah.
A lot of these service bureaus use third parties that are close to where you are. So I know there's a guy who's got a pretty nice setup about 20 miles from me. So they send my requests, my models, to him, and I'm at his whims as to when he decides to print them and when he mails them out. So they're not as quality controlled. And
yeah.
I was glad that I went with my own printer. It's a little bit, the lady who mentioned the resin printers, she may be able to do maybe a little higher quality.
Right here, people. Here. That's her. I say hi to her.
Hello. How are you satisfied with, have you done brickwork?
Have a seat.
Not so much with the resin yet. I've had other friends who do have resins that have pretty decent results. With the key with resin printing is what's even more important is orientation. There is one side that is better than the others. The top side, the one that's the one that's facing the bill plate is the worst.
Okay.
Opposite of the bill plate is the best.
I guess I'm seeing the same thing with PLA. I've been doing some work recently where I want to design my own brick walls. And so a brick is 2 by 3 by 8 inches. and I tried to reduce that down to HO, and I lost all the definition in the bricks. And I went back and did the math, and given the extrusion for me is 0.4 millimeters.
Yep.
I just didn't have the resolution to do
right.
bricks. So I found that a lot of the things I download from Thingiverse, there's a guy. What's your scale?
HO.
I want you to look for models on Thingiverse, and on your search panel, K.A. Brumble.
Okay.
And he does over 100 beautiful structures. That's why I say I'll never buy another structure from Woodland Scenics again. But I went and measured his bricks, and they looked good, but they were not as fine as the stuff I get from Woodland Scenics, which are done by a different technology, but they still look good enough.
Right. I have a friend. What does Craig use? 0.2 mil? Yeah, I have a friend who placed all of his nozzles from 0.4. He went down to 0.2, and he was actually able to build freight cars, contest quality freight cars with a 0.2 mil. But the build time is almost double because of the smaller nozzle. And also, he was actually able to make the grain work in his favor because he modeled 1900.
Yeah.
So he was able to use the grain to his advantage.
Yeah.
So it worked for him. But yeah, that was his trick, was to go from 0.4 down to 0.2 to get that extra resolution.
Yeah, I'm doing something like I told you, the shingles right now, and I'm still doing them at 0.4. I've set my my Cura slicer to work at 0.12, but if you use 0.4 nozzles, that's kind of a moot point.
Right.
So yeah, I probably need to get some more nozzles as well. Yeah.
Yep. Awesome. Well, thanks. I think we're about ready to start. So, all right, cool.
Good. Nice talking to you.
Yep, absolutely.
Kick Kaylee out of my seat. It used to be her seat. She actually gave it to me. Have it back whenever you're ready, Kaylee. All right. So I'm going to switch gears here to the next clinic. This is one I'm actually incredibly interested in on the animation, because I'm still trying to work on that electrical certificate. I need to do some of these things, some of these fancy.
All right, let's roll.
Ready?
Roll.
Get your picture on there. You just don't want that going across.
Thanks for tuning in to this entry-level clinic on model railroad animation using Arduino microprocessors. So what is it all about? You will learn how to add controlled movement, lighting, and sound to your model railroad easily by using extremely inexpensive and simple computers called Arduinos. Well, like what? Let's start with something simple. We will learn how to turn a light-emitting diode, or LED, on and off under the control of an Arduino microprocessor. We will learn how to add a yellow LED to the top of a tow truck. If we can flash one light, then perhaps we can flash two in synchronization. And maybe we can take a half dozen and make them flicker randomly in a dumpster fire. And then let's take a loop of track and add a sensor and a liquid crystal display to create a speedometer. Next, let's learn about another type of LED and a more lifelike way to control lighting for building interiors. Or add sparkles and sound to a water feature. Or make a larger fire. What do you do before you chop up a pine tree? You have to chop it down. And we will learn how to swing an axe, fell a tree, and enjoy the sound it makes. Finally, we will turn back our clocks to the first time we ever rode a carousel. We will go round and round to the music of random Sousa marches, and then let others ride when our turn is over. Before we go any further, if you write down anything in the clinic, this should be it. http://daacam.github.io. github.io. This is my website, where absolutely everything in this clinic is documented. There are copies of the videos you just saw, and chapters which explain the underlying theory. Not into theory? You can go right to the projects, which contain the detailed instructions on how to create the animations we have just seen. Arduinos control the animations through programs, or sketches as they are called in Arduino speak. And I have included the actual code I used to make the animations you just saw, all for free. No programming required. Even a handout you can print with all the main parts of this clinic summarized. I am using this clinic toward my Author Achievement Program certificate, so I am trying to do a really good and complete job. Now that you know what this clinic is all about, it is time for what us engineers call the speeds and feeds. Arduinos are what we call open source, which means that the design is not patented. Many companies can and do build clones of the original design. Clones are generally less expensive, and I use them exclusively. Arduinos were originally designed in Italy about 2003 to teach youngsters how to program. In this clinic, I will teach you how to use programs, but not how to write them. Arduinos come in many form factors, but they all do about the same thing. This is the Arduino Uno model, and is probably the most commonly used by hobbyists. I don't like it. This is an Arduino Mega. It has about 2.5 more connection points than an Arduino Uno. I have one, but I have never used it. This is an Arduino Nano, and all my new projects use it. Why? Well, it is less expensive than an Uno and does everything that I need in model railroading. I don't like the Uno and Mega because when I wire in external components like LEDs, I must jam a wire into a socket and the connection is never truly secure. When I buy a Nano, I buy ones from a manufacturer called LabFin because they have pins already soldered to the board. You can buy less expensive ones and solder these pins, called headers, yourself, but it is a frustrating task that I find not worth the savings. As an accessory to the LabFin Nano, I also buy an expansion board, and I can plug a Nano right in. I can also insert components into the expansion board sockets, and then tighten the screws for a nice secure joint. It is also the least expensive option. What's not to love? I buy over 95% of all my electronic components from Amazon. You can occasionally find Arduino components at trade shows, but unless they offer some especially unique item, I usually buy from Amazon. Chapter 3 of my website lists all of the components I commonly use, their price as of this writing, and their Amazon Standard Identification Number, or ASIN. If you enter the ASIN in Amazon search bar, then enter a carriage return, their website will find the item for you. But be aware, many electronic components turn over quickly, and a part that is available 1 month may be unavailable the next month. If this happens to you, try to search by descriptive terms and make an intelligent substitution. So, how do we begin? An Arduino can do very little right out of the box. It first needs to be connected to a personal computer by the USB cable that comes with it. So let's plug it in. This gives power to the Arduino, and a small LED in the middle of the chip starts to flash, while the LED next to it remains lit. But to make an Arduino do what we want it to do, we have to download a sketch to it, and this requires us to download and use the Interactive Development Environment, or IDE. The IDE is an application similar to a word processor. In it, we can write sketches of our own, or download sketches others write and share with us. The IDE runs under Windows, Macintosh, and Linux computers, but I have experience only with Windows. So how do we get the IDE? We visit the Arduino website at http://arduino.cc/en/main/software. Now let's scroll down about a page worth until we see Download the Arduino IDE. On the right are various systems on which the software can run, and I'll click on the version for Windows 10. The next page gives us the opportunity to contribute to the development of the IDE, and I'll click on Just Download. This website uses the Microsoft Store to distribute the software, and if you are not registered or logged in, you will need to do so. But I am already logged in, so I'll click on the Get button. It's pretty large, so the download takes a while. Now I'll click on the Install button. I'm not going to launch the IDE right away, because I want an icon on my desktop for future use. I click on the Windows icon in the lower left, and then drag and drop the Arduino entry onto my desktop. I can now double-click on my Arduino icon anytime I want to launch the IDE. Now we are finally ready to animate something. I bought a box of 500 color LEDs manufactured by Daikuna, so let's make a yellow one blink. I first take a 10-inch piece of red wire and solder it to the long lead of the LED. I take a similar piece of black wire and solder it to the short end of the LED, and paint the joints with liquid electrical tape and let it dry for about an hour. But before we go any further, let's do a thought experiment. What would happen if you plugged a household lamp that normally runs on 120 volts into a clothes dryer socket which supplies 220 volts? There would probably be a loud bang and some smoke, and the lamp would be fried. The same thing goes for LEDs and Arduinos. My red LED runs on 2 volts, but the pins on an Arduino supply 5 volts. I won't go into the electrical engineering here. If you want the theory, read Chapter 4 on my amazing Arduino Animations website. But to keep my LED from burning up, I need to add a 150 ohm or larger resistor into the line. Although I can add the resistor to either wire, I am going to splice it into the black wire, about 2 inches from the free end. After soldering, I'll insulate it with heat shrink wrap. Different LEDs need different size resistors. If you use too small of a resistor, the LED will blow. Too large of a resistor and the LED will get dimmer. I generally use 150 to 220 ohm resistors for 2 volt LEDs, 90 to 220 ohm resistors on 3 volt LEDs, and 10 to 220 ohm resistors on 5 volt LEDs. So when you buy your LEDs, buy some resistors as well. 150 to 220 ohms is a good compromise. I stripped off about 1/4 inch of insulation from the free ends of the wires and tinned the ends. Unplug the Arduino from the USB cable. I always unplug the Arduino when making electrical connections. If you haven't inserted the Arduino Nano into the expansion board yet, do so now, making sure that it is oriented the right way. The USB connector should be near the D12 pin. Raise the screw on pin D2 of the expansion board and insert the red wire and tighten the screw. If the wire doesn't want to go in, take the pointy end of some decal scissors or some other small object and place it in the socket and raise the flap on the inside. Now insert the black end into the socket labeled GND. This is the electrical ground. This completes all the required electrical connections. so we can plug the USB cable back into the Arduino. Now we need to download a sketch into the Arduino, and I have one prepared for just this project. Launch the IDE application and click on File and then New. An almost blank sketch will appear with just the setup and loop functions. Highlight the entire area and hit the delete key because we won't need any of it. I am not going to teach you how to code, but I am going to teach you how to take sketches from my website and load them into the IDE. So open the website at http://daacm.github.io, and down under the Chapter 4 heading labeled "To view a small program to test blinking a single LED, click here." So click there. A new window will open. Highlight the 13 lines of code and do a Control-C to copy the code to the Windows clipboard. Now go back to the Arduino IDE and do a Control-V to paste the code in the area which formerly contained the code from a brand new sketch. This technique of starting a new sketch, deleting the code from the new sketch, going to the website, copying an existing sketch, and then pasting it into the IDE code area is something you will do for all the projects we will describe today. But we are not quite ready to run the sketch. Remember that there are many form factors for an Arduino? Well, the IDE needs to know which one we are using. So we click on Tools, and then on the Boards entry, and scroll down to the Arduino Nano entry and click on it. We also have to configure the port. Again, we click on Tools, then Port. There will probably be only one entry, and it will probably be already selected. But if not, select the one which is highlighted. We are now ready to run the sketch. In the upper left of the IDE is an icon with a dark green arrow on a teal-colored circle. This is the icon that downloads the sketch from your PC to the Arduino. So let's click on it. Down at the bottom of the IDE, it will indicate that the sketch is compiling, then uploading to the Arduino. In a few seconds, the LED will begin to blink. But this is just the beginning. If desired, we could change the sketch. Remember that the IDE is kind of like a word processor, and alter the number of milliseconds that the light is on or off. Changing the on time to 100 milliseconds and the off time to 1900 milliseconds would turn it into more of a strobe. And now you know the basics of animation using Arduinos. Moderators, could we take a break here to see if there are...
Okay, Jeff, let's see if we can stop it for
pick
just
up
a
the
little
pace
bit.
just a bit.
What's
The
that?
tow truck I used is one from the scene
Let's
map.
pause it for right now.
Pause it.
Okay, great. Now, this clinic's kind of in two pieces. You've gone through the theory, you've seen how you load things, and we're going to now get into projects for the last two-thirds of the clinic. How are we doing? Have I saturated you? Has anybody tried Arduinos before? Anybody got any questions they want to ask before we get more into the projects?
That's been clear, thank you.
Doing okay?
Everybody looks like they're doing all right, Dave.
All right, nobody's drowned in data yet. Okay, let's hit it and let's go for the next half an hour.
Roll it.
There is a small screw on the underside, and if I remove it, detaches the cab and steps from the frame. I took the cab to my drill press and carefully drilled a number 55 pilot hole through the top of the cab from the outside. I also drilled one through the interior. I then enlarged the holes with the number 29 bit. If you don't have a set of numbered drill bits, use a 1/8 inch bit. If you don't have a drill press, use a cordless drill and hold the workpiece gently in a vise or clamp. Now from the inside, I inserted the LED into the hole in the roof and detached it with a bit of CA glue. I ran wires through the interior, then reattached the cab to the frame. But how do we power these things when on the layout? We can't always have them connected to our PC for power. That's where wall warts and barrier strips come in. Wall warts are the things that plug into the wall to power audio components and other electronic devices, and we need one that can provide somewhere between 7 and 12 volts DC and at least 250 milliamps. You may have one lying around from some obsolete device, but if not, you can buy one from Amazon for about $5. You can buy ones with more capacity, I do, which allow you to power more than one Arduino or power external devices which can be controlled by an Arduino. I usually cut off the end of the power supply, peel back several inches from the outside insulation, and use a voltmeter to make sure I know which wire is hot and which wire is the ground. I solder spade connectors to the wire ends and connect it to a screw-type barrier strip. I then use red and black 20-gauge wires to run from the barrier strip to the VIN, voltage input, and GND wires of the expansion board. Using the barrier strip makes it easy to get to a ground point when wiring in additional LEDs or other components, so don't skip that step. Barrier strips come with various numbers of connecting points, and I always buy long ones and then cut them down with a bandsaw. Amazon is expensive for these things, so if you have an electronic supply store locally, you may want to shop there. Okay, let's try something new. I've prepared 2 more LEDs, a red one and a blue one, and connected their red wires into pins D7 and D8, and their black wires to the ground point on the barrier strip. I always solder a spade connector on any wire to be placed on a barrier strip, but it's your choice. I also went back to the website and downloaded another sketch from underneath the Chapter 4 heading, the one labeled, "To view a small program and test blinking a pair of LEDs, click here." We now have 3 LEDs on the same Arduino, but this new sketch will power only the 2 new ones. When we run this sketch, the red and the blue LEDs blink alternately every second. Using the same method as we used for the tow truck, we can install these into a police car. Next comes the dumpster fire, and you are probably getting the hang of things now. I prepared 4 yellow and 2 red LEDs for this project. I now need to tell you that 6 digital pins on an Arduino, numbers 3, 5, 6, 9, 10, and 11, have special powers called pulse width modulation, or PWM for short, which means that they can be made to dim through software, can appear to get dimmer and brighter every few hundredths of a second, which can yield a flickering effect, great for simulating fires. Just prepare your LEDs as before, and remember, even though we are dimming the LEDs through coding, they still need a resistor. I drilled some holes in a dumpster and ran the wires through the holes. I didn't want to solder spade connectors to 6 ground wires, so instead I bundled 3 together at a time and soldered a pigtail to the bundle, insulating the joint with heat shrink tubing, and soldered a spade connector to the free end of the pigtail. I connected the spade connectors to the ground position of the barrier strip. You did use black colored wire for your LED ground wires, didn't you? And then connected the red LED wires into the expansion board positions listed above. The LEDs tended to wiggle around in the dumpster, so I secured them with clear silicone caulk. Don't worry about getting any on top of the LEDs, because doing so tends to diffuse their light, and I like the effect. I added some small pieces of balsa wood inside the dumpster, and you can add tires, pallets, or other junk as desired. The code for the dumpster fire can be found under Project 1. The code in the loop function sets the flicker level for each pin to some value between 50 and 255, 255 being full power, and then resets every power level every 1/10 of a second. 255 is pretty bright, so you might want to play around with the minimum and maximum values I provided. Now for the speedometer, the first project I ever created. No LEDs used here, but we are going to use a light-dependent resistor, also known as an LDR, or photocell, and a 4-line liquid crystal display, a 4-position barrier strip, and a 10K resistor. I'm not going into as great detail for the remainder of the projects, as you can find all you need in the documentation in the website. For starters, I took the LDR and soldered 24 inches of lightweight wires onto the 2 leads and insulated the joints. An LDR is symmetrical, so when hooking it up, one lead is the same as the other. You can use any size or color wire here, just not black, red, or white. I drilled a hole through the track and through my layout large enough so that I could place the LDR even with the track ties. You might even need to remove a tie to make this work. Positions 1 and 2 of the barrier strip are used for the wall wart to provide power to the Arduino. So now is the time to run red and black wires from the barrier strip to the VIN and ground positions of the expansion board. Use masking tape and label the 3rd position of the barrier strip as 5V and the 4th position as A0. Connect one lead from the LDR to A0 and the other to 5V. Take the 10K resistor and wire one end to the ground position of the barrier strip and the other end to the A0 position. Run another wire from the A0 position of the barrier strip to the A0 pin on the expansion board. We should now have 3 wires connected to the A0 position of the barrier strip. Run another wire from 5V on the barrier strip to the 5V position on the expansion board. Now for the liquid crystal display. Run a black wire from the ground position of the barrier strip to the GND position of the display. Note that the display has male connectors, so female jumper wires are needed to mate with it. Run a white or red wire from the 5V position of the barrier strip to the VCC position of the display. Run any color wire from A4 on the expansion board to SDA on the display. Run another wire of any color from A5 on the expansion board to SCL on the display. Our wiring is now complete. Once you apply power, you may need to turn the blue potentiometer on the back of the display to adjust the contrast. Visit the website and copy the code from Project 2 Speedometer section and paste it into the code section of a blank project. But before you run the code, you need to make 2 changes. Around line 179, you need to change the code to represent the length of your track loop in inches. Around line 180, you need to record your track scale. Save your changes by clicking on File, then Save, giving the project a file name of your choice. As they say in Indianapolis, ladies and gentlemen, start your engines. When your locomotive passes over the LDR, the Arduino will start its timer. When it passes over the LDR again, it will report the elapsed time and average scale speed on the display and starts the cycle over again. You can run the locomotive standalone or with cars. I was surprised just how much faster the train ran after it was a bit warmed up. I like this approach for a speedometer on a loop rather than a speedometer on a stick because it handles momentum better, uses only a single sensor, and probably is a little bit more precise. The current version, 0.54, does have a small bug which can pop up when running with short cars, and I am working on a bug fix.
Version 0.55 fixed the bug.
Uses a different way to control the lighting. I used 5-volt LEDs for this project, running at 40 milliamps, more powerful than LEDs we have used before. These LEDs come on rolls, so you just need to use scissors and snip one off. The front of the unit is curved and tends to roll when soldering, so I place the unit curved side down and place a piece of masking tape on it to hold it steady. With the back side up, I pull back a bit of the backing tape. The front of the LED indicated which of the soldered pads was for the ground and which was for power. I dropped a bit of solder on each dot and tinned the ends of a black and a white 28-gauge wire, and then made the soldered connections. I removed the LEDs from my work surface and placed a spot of masking tape over the actual LED. I then spray painted about 2 inches of the wire around the LED, so that the black wire would be less visible when the unit was attached to the ceilings. I made the building interior using 3D printing, but that's a topic for another clinic. You can build room pods with sheet styrene or some other technique of your choice. I decided what business was to be in each room and found images on the web to represent the motorcycle shop on the bottom floor, the bowling alley and utility room on the middle floor, and the bar and the ballroom on the top floor. I glued the images on the building with rubber cement. Drilling from the inside, I drilled 1/8-inch holes at the center top of each room and passed the wiring through the hole. I removed the backing from the LED and pressed it onto each room's ceiling. But how do these lights go on and off at random? I am not going into the details, but if you look at lines 86 through 92, you can see the parameters for what I call a light block. Line 86 says that for light block number 1, the positive wire of the LED goes to pin D7 of the Arduino. Line 87 says that when the Arduino passes the initial power-up test, this particular LED is off. Lines 88 and 89 say that the minimum on time is 8,000 milliseconds, or 8 seconds, and the maximum on time is also 8 seconds. These values are usually different from each other, and the actual time on is some random value between the minimum and maximum. But for this room, I wanted them to be the same. Lines 90 and 91 give the minimum and maximum values for the off time. Line 92 gives the elapsed time when the state of the LED will not change. There are blocks for up to 9 LEDs, and the code is written to cause them each to change as desired. Additionally, line 84 specifies how many of the blocks are actually used in any particular application. So, upload the code to the Arduino, cover the interior with the building shell, and enjoy. I used basically the same code for a waterfall. I used regular 3mm LEDs for this project, so with their smaller current draw, I could use a bunch. I prepared the waterfall with Woodland Scenic Shaper Sheet and then covered it with plaster. I made the first pour with Cast & Craft polyester resin from Michaels, about 3 ounces, tinted with a small amount of Perlex Sapphire solid pigment. I let the resin sit for about 15 minutes until it was as thick as syrup, and then tilted the structure and made the first pour all at once. Within a minute, it was no longer runny. I pressed in a few rocks and twigs and let it harden overnight. The next day, I drilled 9 1/8-inch holes into the feature. I prepared 3 blue 3mm LEDs from Daikuna, 3 white ones, and 3 additional white LEDs, 1 each tinted with Woodland Scenic's navy blue, turquoise, and 1 Tamiya clear blue. I placed the LEDs in the holes and sealed them in place with clear silicone caulk. I let them dry overnight. The following day, I made another resin pour of about 2 ounces, this time with clear resin, and let it dry overnight. Finally, I gave the whole thing a coat of dull coat. Oh, and I added sound. The sound chip and amplifier each require 5 volts, and the power supply provides 12 volts, so I had a problem. I could run it from the 5-volt pin of the Arduino, but I was afraid too much power would be consumed, so downstream of the power supply's barrier strip, I wired in a buck converter, or voltage regulator I purchased from Amazon. Downstream of the buck converter, I wired in another barrier strip. But before I wired in the MP3 player and the amplifier, I dialed down the converter to 4.2 volts, because the web said it ran better at this lower voltage. This must be done before attaching the MP3 player and amp, because out of the box the converter delivers 35 volts and we don't want to fry the audio components. The MP3 player and amplifier are just chips with no convenient way to mount them to a fascia board, but I found a solution. The space between the pins of the Arduino is 1/10 of an inch, or probably something close to that in metric units. This same spacing is used between the pins of the MP3 player and the amplifier, probably some industry standard. Perhaps we could re-engineer the Arduino expansion board to fit these two audio chips, and that's what I did. I cut the expansion board lengthwise on my band saw. Because the expansion board has 15 pins on a side, and the MP3 player has only 8, I cut one piece of the expansion board crosswise at pin 9. With the sacrifice of pin 9, that left me with two pieces, one with 8 pins and one with 6. But while we need pins 1 through 8 on one side of the MP3 player, we really only need one pin on the other side, pin 16. And we don't even need pin 16 for every project. Unfortunately, the distance between the two rows of pins was not the same between the Arduino and the MP3 player, so I took a thick piece of sheet styrene, placed the MP3 player into the two expansion board pieces, and hot glued the pieces to the styrene. Bingo! I invented a way to make an expansion board for the MP3 player and the amp. I have used a bandsaw for years, but using large saws can be dangerous. If you don't feel comfortable with making these cuts, ask someone with more experience for help. Safety first. Once the MP3 player and amp have their power connections, I ran wires from pins 7 and 8 of the Arduino to the MP3 player, pins from the MP3 player to the amp, and from the amp to a speaker. Chapter 9 has all the details on the wiring. Because the MP3 player has its own built-in amplifier, you can get by without a separate amplifier. The MP3 player can be wired up directly to the speaker by using different pins. But then there is no way to dial the volume up or down, except through software. There is a micro SD card in the MP3 player, on which I placed an MP3 file of falling water I downloaded from the internet. Actually, it was part of a relaxation video, and I stripped out just the audio. No need for stereo, so I removed the second track using the free audio editing software from Audacity. I connected up a wall wart and barrier strip and plugged it in. Lights, sound, action will come next. I know somebody watching today has to have visited the magnificent HO layout in the Chicago Museum of Science and Industry. Did you see the falling tree back where they modeled the area around Seattle? I had to have a falling tree. This is the first project where I used motors. Arduinos can drive small stepper and servo motors directly without a separate motor shield. I use servos because they are absolute in positioning. They always know where 0 degrees is. Steppers are relative. I wanted the tree and the lumberjack to always know their starting position. Like the waterfall, this project is going to use audio, so like before, I wired in a buck converter, barrier strip, MP3 player, amplifier, and speaker. The motors for the lumberjack and the tree both require between 4.2 and 5 volts, as well as ground. And fortunately, we have that coming out of the buck converter. To control the lumberjack, I ran a wire from pin 2 of the expansion board to the control wire of the servo. The other 2 wires, red and black, are for power and ground and should be connected to the output of the buck converter. A wire from pin 4 should be connected to the wire controlling the motor, which controls the tree. I also wired in a display and push button to start the animation. The wiring for the display is similar to what we used on the speedometer project, and wiring a push button switch is described in Chapter 8. The mechanicals are the most difficult part of this project. How do we mount the tree to the motor and the motor to the layout? How do we connect the lumberjack to his motor and make him turn? There is just not enough time to go into these specifics today, but that's where the website can help. If you want to see the details, go to the heading for Project 4 Lumberjack and open the videos there. For now, know that I purchased the figure over the internet at modeltechstudios.com, but lots of options exist for this. I created simple mounting blocks out of lumber and attached them to the servo. The servo for the tree is mounted horizontally, and the servo for the figure is mounted vertically, and I glued them with Titebond 2 glue. I used epoxy and Teflon plumber's tape to attach the tree to the motor's arm. I made a platform and axle to hold the figure, and took evergreen tubing to construct a transmission. Placing the lumberjack accurately is not as tough as it may seem once you know the trick. If I were to do this project again, I would visit my hobby shop and ask for advice on servos. The low-cost ones I bought were problematic. Originally, the metal-geared one I used to rotate the lumberjack was very noisy, so I replaced it with one using plastic gears. I really disliked the open slot for the tree, but the motor manufacturer did not offer a right-angle horn that might be used to hold a door that would rotate out of the way when the tree began to fall. Better servos, like are used in radio-controlled cars and planes, might have better options for horns. Or perhaps I need to make some of my own using 3D printing. Finally, we have the carousel. The carousel is an old IHC kit, which can still be found on eBay or at swap meets. The overall design is similar to the lumberjack in that it has audio circuitry and a display. It uses a toggle switch instead of a push button, but the switch wiring is quite similar. It uses a single 12-volt Hankscraft motor to drive the carousel, but requires a second buck converter to drop the voltage to where the carousel is spinning at a safe speed. I added a wire from pin 16 of the MP3 player to pin 9 of the Arduino. Although not needed for earlier projects, this wire tells the Arduino when a song is finished. When a song completed, I used a relay controlled by the Arduino to stop the carousel's motor. I found carousel music on the web by searching for Sousa marches and downloading the MP3 files by right-clicking on their progress bar and saving them to the SD card. I found 14 of them that I liked. However many you choose, when you download the code, change line 23 to indicate the number of songs you place on the chip. The trick to this project is mounting the carousel and Hankscraft motor successfully. And again, the mechanicals can be found at the website. Without going into the details, I drilled a 1 3/4 inch hole in the layout. I made a mounting block out of lumber and drilled a 1 3/4 hole for the motor in it. I aligned the hole in the layout with the hole in the mounting block, clamped them, and drilled 4 holes for machine screws, aka bolts. The mounting block is separated from the layout bottom using spacers. After I clumsily broke off the plastic axle on the carousel, I used a 1/8 inch steel rod to replace it. I connected the new carousel axle and the Hankscraft motor with a coupler I found on Amazon, and secured it to the motor and carousel rod with the set screws on the coupler. Well, folks, that's about it for amazing Arduino animations for 2020. If you have any questions or find any areas where things could be improved, just drop me a line at acmans@charter.net. Don't forget, YouTube is an amazing source of tutorials on all things Arduino and model railroading. I hope you enjoyed the ride. Time for more questions. Thanks for...
There we go. Well, again, this is kind of like drinking from a fire hose, but the idea is this thing is approachable. So if you've got something that you want to kind of synchronize with electronics, Arduinos can be very useful. Their main problem is that they are limited to how much current they can drive. So like that 12-volt Hankscraft motor on the carousel, that took too much current. So I had to drive it through a relay or a transistor to control the on and off for that motor for the rotation of the carousel. So, Jeff, what do we got?
Anybody got any questions for Dave on that one?
All of this is available on his website?
Yes. And we will post the recording of this to our YouTube channel as well, so you can find it there. And then, this website is...
I'll probably have to watch it 16 times.
No, you will, but it's worth it. And the website is so extensive, it's ridiculous.
I got my author certificate back in August, and I've created 5 clinics, so that was part of it. But I think I got as much credit for the programs that I did for this Arduino clinic. Writing these sketches, writing these programs is also authorship. And I convinced the national folks that it was worth it. Plus, my degree is in mechanical engineering. I was a thermodynamicist. I loved the way heat moved around. So I'm not that good at mounting things, and certainly not electronics. But as I learned about the Arduinos, I wrote the stuff that's on the website, the theory. So if you want to understand about why you need particular resistors for an LED or other things, that's there too. So it's got projects and it's got theory.
Good. Thank you. Yes, Steve?
Yeah, Dave, I just want to say, you're probably not going to get into programming Arduinos anytime soon, but when it comes to quality of presentations, it's really excellent.
Well, thank you. Remember, I'm a pretty good computer scientist now, a lot better than I was an engineer. So some of the stuff there may be more intricate than people would normally want to get into. So if I sweated through it, there's no reason to make you sweat as well. My favorite project is probably the speedometer. My layout has got 3 loops on it. And I do some consisting on locomotives, and it was fun to look at them and just see how fast they were going there. And when I had the bug that I mentioned there, that was when I was putting cars behind locomotives, and that LDR, a light-dependent resistor, well, when a gap came between a locomotive and a car, or one car and another, it was triggering. And I didn't want it, triggering until it got back around the loop again. So that was a lot of code before I got that to work reliably. And I give it to you for free. I hope you enjoy it. That speedometer, I was really surprised after a loco had been running for about 10 minutes. It was running about 50% faster than when I put it on stone cold. So it's kind of interesting. Plus, it's just fun to see the numbers change.
I think Don's going to ask you a question here.
Hey, Dave, the problem with the gap between cars, like those photocells could be hooked. You could put 2 in series, and then they both need to be over a gap. They both need light to trigger your output. So I think then, if they were like an inch or 2 apart in HO, one would be shadowed, and you wouldn't have to do it in code.
Are you a guy who uses Circuitron stuff?
Unfortunately, no.
It's funny that you mentioned that, because a lot of the Circuitron electronics, like for block detection, put 2 LDRs at one end and another pair at the other, so you can essentially know directionality, which way the train's going, in or out of the block. So it's a very similar thing. But remember, I'm a computer scientist and a code guy. And so I don't know if you ever heard the term WYSIWYG for computer graphics. What you see is what you get. Have you ever heard of Wiggy Woo?
No.
What you got is what you use. So I had software knowledge, but you're totally right in your observation.
A lot of other things can't be casually hooked in series, but photo cells happen to be one you could.
Yes, you're quite right. Yeah, capacitors being not as well behaved.
All right.
Great. Thank you very much.
Good presentation.
Well, I thank you all for your hospitality. I teach other clinics on building billboards, on doing custom decals, and one that Jeff wanted, but we didn't see today, how I design 3D models using PowerPoint. I design them in 2D, extrude them, change the extrusion height, and then I've got a lot simpler way to do some really kind of fun type of models, and that's all on my website as well. So Jeff, I'm going to turn it back over to you, and thank you and your division for hosting me today.
No, thanks, Dave. You know, I think back to before COVID, and these are two clinics you never would have had any other way, right? So this division didn't do this sort of thing before. So, you know, if you want to look for a little silver lining on COVID, you know, you're going home today with knowledge you wouldn't have had any other way. That kind of forced us to do this technology-wise. So I appreciate it, Dave, all the way from St. Louis, and hopefully some of us will get out to the National Convention next year. Maybe we'll see you.
Well, I hope so, and I appreciate it. I am now over halfway to my association volunteer certificate, and I've never held an office within the division. But I've done these clinics probably about 24 times, a little more, and it's worked out for me as well. So share the wealth.
Will do. Thanks for dialing in, Dave.
All righty. See you guys.
Thank you.
And you too, ma'am.
Anybody else got anything else, or that was the end of the program? We don't have a layout tour today because of it. Don?
Have a good one.
I got a list from Greg Lane when I took over the layout tour coordinator position, and I printed it out here. If you have a layout that we've ever seen and not seen, would you just come along and see if you're on the list? And if you're not, would you write your name down, contact information, so we can get you on the list if you're all interested in ever showing a layout or the division needs over the regional. Like to more about it.
The D10 is saying something with his photo background.
Okay, we will do that, Don. Thank you.
This might be a good thing. This concern about internet security.
Yeah, we could post names but no addresses.
Right. Or you could, or post a request to give you the information, too, for the folks who aren't here today. So, it looks like Ken needs to give you his information. He looks like he has a layout behind him. So, all right. Thank you. Anybody else? Yeah.
I went to the convention last week. Fantastic. And I'd like to thank Haley for being chairman of the photo contest. Did a fantastic job. The photos were incredible, especially the auto. They were incredible.
Yeah, we had very good diversity and very good numbers. 33 entries this year. I think that might have been our highest in the last 5 years. So really happy for the turnout, really happy to see a lot of people, and a little plug for the photo contest. I've had to encourage submitting, even if you may not think it's not good in your opinion, you never know, because everything, photography is very relative, so it's one of those things you just don't know until you try. So I would highly encourage anyone who takes photos, who will be always taking photos, to print something and get it submitted to our contest next year. My goal is to make next year to be one of the largest in photo contests in the entire region's history. Highly encourage it. There's, it's a lot of fun. It really is. It really is a lot of fun.
Okay.
It's probably the easiest thing to take a photo.
Yeah.
By the way, I got a couple of different very much taking place in prototype and I will mention.
Excellent. Congratulations. All right, that it? Everybody enjoy the rest of your day. Enjoy the rest of your weekend. Take care. See ya.